Hello, and welcome to Astronomy 100. In a previous segment, we were talking about the different properties that stars have. We talked about how we determine the sizes of stars, their distances, their masses, how much energy they produce, and other things. Knowing the properties of the stars, of course, is really central to astronomy because when we understand the properties of stars, we can start to figure things out like how they form, how they live, how they produce their energy, and why they ultimately die. In this segment today, we're going to start to tie things together, but we're going to do one more very important thing, and that is we're going to begin to categorize the stars. Now, when it comes to categories, categories are a very important part of any science. If you think about biology or zoology, think about how important it is that there are categories that we put animals into. Obviously, the Earth has many different types of animals, and when it comes to creating categories, it helps us get some sort of order out of the chaos. There are many different types of dogs, there are many different types of cats, and there are many different types of horses. And so by creating categories allows you to understand how all of this is sort of put together and comes into a way to understand them individually. For instance, if we just say somebody has a dog, well, that tells you what type of animal it is. But usually the first question somebody is going to ask is, what is the species of your dog? What type of dog do you have? So when it comes to stars, we also want to create categories as well. When you look at the sky, it may seem like there are many, many stars out there, and there are, and it may look like they're all slightly similar in many ways, but they do also have some important differences. So creating categories allows us to understand the nature of the stars a little bit better. And in addition to that, categories allow us to understand the big picture. When we can get an understanding of the different types of stars, we can get a better understanding of how stars are formed, how they exist, and why they ultimately die, based on the type of star that it is. And then lastly, we need to find a convenient way to be able to create categories. What we know is there are a lot of things about stars that you can determine. You can determine a temperature of a star by looking at it. Those are the colors of the stars. But we want to dig a little bit deeper. So what I'm going to show you is how we determine categories for the stars based on some very fundamental properties of the stars themselves. So let's go to this first slide. Now let's pretend that we are looking at a group of stars. In this case, we just have a handful of different stars. They're different luminosities. They look different in their brightness. But what if we were to figure out a way to look at them in a way that will tell us more about the star itself, other than just the color of the star or the way that it looks to our eyes? If you remember from a previous segment, we talked about the concept of the spectrum of a star. If we take the light from a star, and we pass that through a slit and then through a prism, we will open up its light into the colorful components that we normally don't see with our eyes. If you remember the red, orange, yellow, green, blue, and violet colors that come from stars. If you also remember from that segment, when we look at the stars and look at their spectra, there are dark lines that appear in the spectrum of a typical star. And if you recall, we call these absorption lines. So every single star has the ability to show an absorption line spectrum. So let's pretend that we're actually going to do that. Every one of these stars is going to now reveal its absorption line spectrum. Now you'll notice they all have the same type of spectrum. They're all absorption lines. None of them are emission lines. And so these are all colorful backgrounds with certain dark lines present. And at first glance, when you look at all of these spectra, it seems as if they're all identical. But if you look very carefully, you'll notice the dark lines. And in some cases, you have stars with lots and lots of lines. And in some cases, you have stars with very few lines. An example is this star right here reveals lots of lines, whereas this one does not. This star right here has very few lines, but notice that the lines that you see here are different than the dark lines you see here. So imagine if we created categories based on the lines. For instance, one category could be stars that have lots of lines. Another category could be stars that have very few lines. A third category could be stars that have lines here, but not here. And if you look around at all of the variety that you see here, you'll notice that this star's spectrum looks identical to this one. So we could take this star and put it in the same category as this star based on its lines. This star here has lots of lines that are identical to this one. So let's pretend we could make a category for stars with lots of lines, and both of these stars would go in that category. So the appearance of the details, the characteristics in the spectrum of a star allows the ability to create categories. Now what I'm going to show you is how it is that we create the categories that we use for the stars that we see. And even though there are billions of stars that you could potentially see through a telescope on any given night, there are many hundreds of billions of galaxies, each full of stars, the numbers seem overwhelming. Might surprise you to know, though, that we can reduce all of the stars of our universe and their different spectra down to only 7 different types. So it's as if of all the types of cats that there possibly exist on our Earth, that there's only 7 types, that all of them fit into one of those 7 categories. So every single star in our universe is going to be one of 7 categories. And so let me show you the actual categories here. This set of pictures here, these are real in this case. What you're looking at is the spectrum of a star. Here's 7 of them. And what you'll notice is they all look very similar. So this spectrum has all the colors of the rainbow, so does this one, et cetera, et cetera. And in case you're wondering, these are the actual names of these stars. Not terribly exciting names, but most names of stars in astronomy are not that exciting. So this star here, if you take its light and pass it through a spectrometer, you'll get this spectrum right here. Same with this star, and so forth. Now, what I want you to notice is their similarities. They all have red, orange, yellow, green, blue, violet backgrounds. But notice how on the bottom here, this star has lots and lots and lots of lines. Many, many lines, hundreds of them in fact. Whereas this one up here shows very few lines. Notice how they have some lines that are similar. For instance, this line right here comes from the element hydrogen, and you'll notice that it is common in all of these stars. Same over here, this dark line comes from hydrogen, and you notice it's the same in all of these stars. So these are actually examples of each of the 7 different types of stars. Some stars have lots of lines, some have very few. Some stars have lines that are very, very dark when it comes to this hydrogen line. Some stars have that same hydrogen line, but not as dark. And so through a fairly complicated historical approach to this over many, many years, astronomers finally figured out that there are actually only 7 different categories, meaning every single star in our universe has the matching features that would match one of these 7 categories. So our sun has a spectrum that looks like one of these, and I'll tell you which one it is in just a bit. So every star spectrum has characteristics that allow us to create categories. Now, the history of this is a little bit strange because when this was first figured out, the initial intent was to create categories based on letters of the alphabet. The idea would be that one category would be called category A, and the second category would be category B, the third one would be C, the fourth one D, etc. Make things simple. Well, through some misunderstandings of the physics of what is actually going on, those original lettered categories had to be rethought. And so the lettered categories that started off alphabetical got shuffled and rearranged in a way that is more accurately portraying what is truly going on inside of the star. So the naming of the categories, let's first start with that. Let's go to the screen here. This is called stellar classification, meaning we are classifying the star based on its spectral features, so stellar classification. And when it comes to the features, again, the categories were originally meant to be alphabetic, but because of a twist of the history of this and a misunderstanding, they got shuffled into the lettered sequence that you see here on the left. So the original category A is no longer the first category. The original category O is now the first category. The original category B is still the second. So instead of A, B, C, D, E, F, G, etc., the new sequence is actually O, B, A, F, G, K, M. So these are called spectral types. A star that has these features is in the category called spectral type O. A star with these features is spectral type B. These features, spectral type A, etc. Now, there's a lot of very complicated details that goes into this, and we're not going to worry too much about that, but here's what I want you to notice. Notice that the star on the bottom has lots and lots of lines. Stars that are spectral type M are stars that have lots of dark absorption lines. Stars that are spectral type O, you'll notice, have very few lines. That's very, very typical of a star with spectral type O. And the reason why there are lots of lines for some stars and not many lines for other stars ultimately comes down to the surface temperature of the star. The idea is stars that are very, very hot have the ability to make the electrons that are orbiting around the nuclei of those atoms that make up the star. Those electrons have the ability to strip completely free. So you have a bare nucleus with no electron. And if the temperature is high enough, you'll have a bunch of atomic nuclei without any electrons. If you don't have any electrons attached to nuclei, they can't jump energy levels and they can't create any lines. Stars that are very cool are allowed to keep their electrons around their nuclei, and the atoms that end up being part of the star are able to make their electrons make lots of jumps from higher levels to lower levels, which creates lots of lines. So ultimately, the temperature of the star, the surface temperature, is responsible for the nature of the lines. Stars that are spectral type O are very, very hot on their surfaces. Stars that are spectral type M are relatively cool on their surfaces. So OBAFGKM, the spectral classification sequence, is actually a range of surface temperatures, hot stars all the way down to the coolest temperature stars. Let me give you some numbers to help you understand. A star that is a spectral type O is a star that might be 35 or 40,000 degrees. A star that is spectral type M might be just 3,000 degrees. These are kelvins, by the way. So it is clearly a range of surface temperature, hottest stars to coolest stars. The problem, though, is that we have now made this complicated because instead of a nice A, B, C, D, E, F, G system, which is easy to remember, we have categories that are O, B, A, F, G, K, M. And it's an important sequence to know. All astronomy students are encouraged to learn this sequence, to memorize this lettered sequence from O to M, O, B, A, F, G, K, M. Now, it would be easy if we had a nice convenient tool to remember the sequence. And for this class, I encourage you to memorize the actual sequence. It'll be something that we're going to need in a future segment. So make sure you commit it to memory. So what I'm going to do is give you some help. Traditionally, this sequence being something that doesn't form a word, it's not really easy to say as a word. Obviously, there's some consonants and vowels in the wrong spot. So what we do to help you remember this sequence is we create what's called a mnemonic device. What it is a sentence where each word in the sentence begins with one of these letters. And so the one that has been traditionally taught for many, many years, probably going on 75 or 80 years by now, is the one that was, well, it says, "Oh, be a fine girl, kiss me." And when you look at this, you'll notice it does sound very old, right? "Oh, be a fine girl, kiss me" is not something we normally say in our contemporary world. But it's actually quite useful. Notice OBAFGKM. The nice thing about it is the girl can be guy if you prefer to kiss guys, and it's still OBAFGKM. So it is still one that works. It is a little outdated. And the idea is if you can remember the sentence, you'll know the spectral classification sequence. Here are a few other ones that I found on the internet, of course related to an astronomy class. This one says, "Oh brother, astronomers frequently give killer midterms." Still OBAFGKM. And then one last one related to education. "Oh brother, another F's gonna kill me." Whichever one you want to come up with is fine for you. There are websites out there that have hundreds of them for you to choose from. The point is, you need to know the sequence. OBAFGKM are spectral types. There are stars called spectral type O, stars that are called spectral type M, and everything in between. Turns out the sun is a spectral type G. And so all of its characteristic spectral features match those of all other stars of spectral type G. So every star in the universe is going to have a spectrum that is going to fit one of these 7 categories based on the characteristics. And what we will find is there's a lot of information just simply based on the spectral type. And what we'll see is how the spectral type of a star reveals other information, as well as help us understand how stars are formed, how they produce energy, and why they ultimately die. But that's a topic for another segment. I hope you'll join me.